Sorry about those technical difficulties. We're just going to start this one over again. So we decided already that we had x-intercepts at nowhere. It doesn't cross the x-intercept, so there are none. Try the x-axis. Then we talked about y-intercepts. That, oh, look, it crosses right there at 0, 2. Whoops. And then we're moving on to domain and range. Now, domain and range, domain is all the x's if you remember, so I was using this little handy dandy tool line here. So I start middle of the graph. I'm going to move left. I always go left first until I run out of graph. Well, this right here, that arrow means it's going to go on forever and ever. Well, in math language, forever and ever over here is negative infinity. And over here is positive infinity. Negative to let you know we went to the left. So as far as the domain's concerned, our left number is negative infinity, comma. Now I'm going to use my blue line again. I'm going to start about the middle again, and I'm going to go right until I run out of graph. I keep going. About right there, I run out of the graph, and that's at x equals 1. Remember, domain is all about x's. So then we decide if it's open or closed. Infinity, negative infinity, is always a parenthesis. And then if you look at this green dot right here, this is closed, which means that one will have a bracket around it. Okay, let's talk range. Range again is the up and down. So I'm going to start with the lowest point, start about in the middle, see how low I can go, when do I have to stop. Oh, right there is when I stop. That is when y equals 0. So I'm looking at the y's now, or sorry, y equals 1. I'm looking at the y's now, not the x's. So we start at 1, comma, and then taking the purple line, and I'm going up, 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 and tell me where to stop. Now the graph doesn't end there because it goes on forever, right? It goes on here, and I can just constantly going up, make my line longer, whatever. It goes on to infinity. And again, this guy right here is closed, so we're going to put brackets. Okay, next one. Look at this one. Let's start with the easy stuff. X and Y intercepts. Looks like it crosses right there and right there. So our X intercepts are at, that looks like about a half, 0, and then 2 and 0. Y-intercepts right here at 0, -1. Okay, domain, we're looking for a left and a right spot. So let's get our little handy dandy blue line. I'm starting in the middle of it, and I'm going left, and I'm saying, okay, a far left, when do I run out of graph? Well, right there's the end of the graph on the picture, but it's got an arrow, which means it keeps going forever and ever and ever, which means so does my leg. Uh-oh. I lost my stick. Oh, he's back over here. Magic. Ta-da! Did you see him pop over there? Not I. Okay, so domain, my left was negative infinity. Now let's do the right side. Moving to the right, moving to the right. Looks like I ran out of graph there at 4. There's not an arrow on the end, so it doesn't keep going on forever. So we're going to put 4 there. Negative infinity is always a parentheses. You're going to look here at this final point, and you say, oh, that's open, which means 4 gets a parentheses as well. Okay, range, we need our horizontal stick here. Okay, taking a graph, going down, 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 down. It has an arrow. It goes on forever and ever. So our range is also going to start at negative infinity because it's the down one. Okay, and then we're going to take our line again, and we're going to go up, 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 up to, looks like 4. And again, it's open, so it's open. That's just a fluke. They wouldn't normally always end up at the same spot. Same domain and range. It's possible. It's just not always the case. Okay, this one right here. Let's see, x-intercepts. Looks like it crosses right there, and that's it. So at 0.5 and 0, y-intercepts. Looks like it's -1 again. 0, -1. Okay, let's try domain. Here's my little blue stick. There. Yes. Come here. Come here, Mr. Stick. Starting in the middle of the graph, I'm going to go left, 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 left. Oh, there's an arrow on it, which means it's going to go forever and ever. All right, so there's a left point. Okay, going back to my graph. If I start here and I go to the right, 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 uh-oh. My graph stops there at x equals 1, right? I would have to jump over to get to this side, but there's a big gap there. So technically my graph, part of it ends right there at 1. And it's closed. So we would put a bracket. Now we just have to list that second set. So here we are, we got stuck here, we jumped. This one, the farthest left is 4. And the farthest right is if you go into forinity, forever, infinity, try to say them together. Parentheses for infinity. 4 has an open circle, so you would say like that. And then we talked about a way to show that 2 intervals go together, and that's with using a U. So this domain has 2 separate intervals on it. Okay, let's talk range. So here's my fancy little stick. Oh, let's get this blue one out of the way. Okay, start in the middle of the grave. Good Lord. Going down, goes down forever and ever and ever. So the range goes from -infinity, that's the lowest, up to right there it stops. So it goes up to 1. That hole is closed, so it's going to be a bracket. But there's another set. There's a hole right here. We can't go straight from it, but we can jump over onto this other one and start a new interval. This one starts at 2 and goes forever and ever, up forever and ever and ever, up to infinity. 2 was open, so I put a bracket there, sorry, a parentheses there. And then we put that ugly U. Ugly, there's no frillies to it, nothing pretty, gosh. And that's the range. Okay, next is what's called extrema. This is just maximums and minimums. So what happens with these graphs, especially polynomials, is it doesn't just have a vertex where there's one maximum or one minimum. There can be a whole bunch of them in any of the graphs. So the definition of an extrema, max or min, and this is important, it's the points at which the graph of the function changes from increasing to decreasing or vice versa. So what do I mean by increasing? Increasing is as if you're sitting on the graph and you're going up as you're riding the graph, and then all of a sudden you change, and now like a roller coaster, you're going down. That would be a maximum or minimum. And then you're still riding along, you're always going downhill, right? Then your roller coaster changes and it goes back up and back down. So all of these points right here are considered maximums or minimums. They're called extrema. This is obviously a hill, a big guy, right? Top, it's a maximum. And then these guys are low, they're valleys, so they're going to be your minimums. All right, other things that you need to know is a polynomial of degree n can have at most n minus 1 maximums and minimums. It's not always going to have that amount, but that's the most it can have. So if I gave you a 3rd degree polynomial, could this be the answer? No, if it's the 3rd degree, it would have at most 2 hills and valleys, maximums and minimums. To define it, this word local right here, another word is relative. Same thing. When you are asked for local maximums or minimums, that's talking about these points, these 4 of them. There's another word that's called, another type that's called absolute. and that's the highest actual max and the lowest actual, sorry, the highest X and Y value over the lowest X and Y value, as long as they're on an increasing to decreasing turning point like that. But we're not worrying about absolute this time. We're just going to talk about what the extrema are. This is the key word to look for. Okay, let's talk about this one. Here's the equation. Here's the graph. There are at most 2 extrema. So you can have 1, you can have 2, but you can't have more than 2. So looking at the graph, they're pretty easy to identify. Here I am riding along, I hit the top, and I change direction and I go down. And then I'm down, I change direction and I go up. So it's just like riding a roller coaster from left to right. This then is at the top of a hill, so it will be a max. This is at the bottom of a valley, so it's going to be a min. So we've got a maximum at 0, 0, and a minimum at 2, -4. You guys have dealt with maximums and minimums before, so it's no big deal. The only difference is now there's going to be more than one. Okay, next let's talk about increasing and decreasing. Now, like I just said, like it's a roller coaster for a polynomial, if you are riding that little graph, like a little choo-choo, chugga, 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 here it is going down the graph, all of a sudden it hits this point right here, that's a minimum, and it changes direction, and it starts going up the other side. The x value at this minimum, that's the changing point. So if you look at the choo-choo and picture it and it's going downhill, that's a decreasing portion. And then it changes directions, and directly after that will be an increasing portion. So this is decreasing. This is increasing. Okay, same thing here. Now he's riding the graph, going uphill over here. So uphill means increasing. Change direction, starts going down, and that's decreasing. So all you have to do for these is identify those maximums and minimums, and then use those to help you identify the intervals where the increasing and decreasing values are. So we've got a minimum right there, a maximum right there, minimum, and that's it. So that right there, this minimum, that maximum, and that minimum, those are our turning points. So our interval has now been split up into 3 pieces. This piece over here, this piece here, 1 piece there, and 1 piece there. And what we've got to say is, which ones is it increasing on? Well, right here, in this portion, it's going downhill, so that would be a decreasing. Then it changes direction, so of course it's going to turn into an increasing. Changes directions again because it hits that max up there, so now it's decreasing. It's always going to alternate like this. And then here at the end, it's going to be increasing again. So under increasing, we have this one right here was increasing, and this right here was increasing. So to describe those, we would say from -2, this is -1.5, I've got a little messy going on here. -2, comma, -1.5. We're just describing it, so you put it in parentheses. And from, this one right here is -1. So from -1 to, this goes out forever in that direction, infinity. And those are increasing. Now, if we wanted to talk about decreasing, that would be this interval, right? So decreasing right there. And then this little interval inside there because it was also going downhill, right? Let's write those out. So this far one on the left, it's an interval just on an x-axis. So the far left it goes is -infinity to -2, and in between -1.5 and -1. So I'm pulling those numbers directly off of that graph.